The Queensland Fire and Emergency Services (QFES) is the main provider of fire and emergency services within Queensland. The service aims to protect and prepare people, property, and the environment from fire and other emergencies. The technical proposal of the innovative web application, Queensland Fire Tracker, is to support the work of the QFES through the use of open sources of data. The target audience of Queensland Fire Tracker is the QFES, aiming to support the work of these individuals. It is intended to function through displaying live fire locations to the user. It will utilize data including previous fire locations and fire station locations provided by the Queensland Government Open Data Portal. The digital solution will provide an ease-of-use fire tracker that can be utilized by the public. Individuals will be able to access Queensland Fire Tracker and utilize it to understand where fires are currently burning. The technical proposal will be presented to the QFES in the form of a multimedia presentation, using communication appropriate for a technical audience in the hopes that the application will receive funding for future development. The digital solution will make use of an open data source that is distributed for public use via the Queensland Government to make inferences about the implications for the proposed innovative digital solution. The digital solution is being proposed for development due to the increasing danger and threat of bushfires within Australia, as seen through the recent Black Summer bushfires. The application will aim to warn residents of Queensland of any fire danger and provide a live tracker of current fires ravaging the state, possibly saving lives. The application will be developed in multiple coding languages. For the design of the application, HTML and CSS will be applied to form an appropriate user interface, incorporating many visual and usability principles. Furthermore, PHP and SQL will be implemented for the functionality of the website, allowing the application to function appropriately. Mind maps are a great way of visualizing points that can be used to translate ideas from the mind into a visual picture. Below is a mind map which demonstrates the technical proposal of the web application task. The digital solution will follow an appropriate analysis of the problem via the use of the mind map. Demonstrated is the prescribed criteria, self-determined criteria, and constraints that will apply to Queensland Fire Tracker. The prescribed criteria are required characteristics of the project as defined by the target audience. The self-determined criteria are key functions of the intended prototype of the project, and the constraints are restrictions that may be present in the task. The innovative web application will be developed for the QFES. To utilize the web application to its full potential, an internet connection is a necessity. Users will be able to view live updates for current fire emergency situations and view the fire locations on a map. Users having access to this data via an internet connection should not be an issue, because in 2016 to 2017, 86.3% of total Queensland households had an internet connection. However, if the individual does not have an internet connection, he or she can use mobile data, if they own it, or a free council computer with internet access. Thus, the demographic for the application intended to be developed for the QFES is targeted at adults over the age of 18, because they are most likely to be online the most time compared to the other age groups. The digital solution will provide a detailed user interface that has been constructed carefully to appeal to the target audience. The web application will successfully incorporate CARP principles to express a visually appealing user interface towards the end user. Contrast will be utilized so that writing or other elements can stick out from the background, enhancing viewer comprehension. Alignment will be implemented so the buttons or input boxes, as well as other elements, are coordinated and visually appealing. Repetition will be introduced into the user interface. Repetition will be used so that the buttons or input boxes, as well as other elements, have common dimensions, conforming to the alignment principles. Proximity will be utilized within the user interface. Proximity will be applied so that images are within the proximity of its respected context. Furthermore, usability principles will also be implemented so the user can utilize a web application successfully to achieve an end goal. Accessibility will be implemented into user interface so that many users receive a positive experience. The website will also have an easy learnability. Additionally, safety will be applied through the use of a warning before the user deletes his or her account. Solution 1 is a live fire tracker map developed by the Queensland Government. Solution 2 is a live fire tracker map developed by the Government of Western Australia. The existing solutions demonstrated display a poor and inefficient solution to mapping current bushfires. Both digital solutions fail to employ multiple CARP and usability principles. Without CARP principles, the page can be hard to navigate and visually unappealing for the user, decreasing the likelihood that the user will have a successful experience with the application. Additionally, usability principles, mainly including accessibility as well as learnability and effectiveness, are lacking within the solutions demonstrated. Both fire maps fail to display the orientation that is critical in mapping and familiarizing users who may not know the map of Australia. Furthermore, both solutions have performance issues present within the map. When zooming in on the map, the user's frame rates drop. In Solution 1, some information on the page is irrelevant and does not add much meaning to the overall interface. However, both websites have a key that helps enable users to understand the information that is present within the map. The existing solutions will influence the development of Queensland Fire Tracker as the web application will improve upon the mistakes that were present in the websites and analyzed. Queensland Fire Tracker will require the use of open data sources to provide information on fires and fire station locations throughout Queensland. The section will analyze two important datasets critical in the functionality of the web application. An urban fire station's location will be analyzed to provide relevant data to the user through fire station locations that may be near. Furthermore, live fire locations will be provided via the collection of data from NASA satellites. These two datasets are CSV files, allowing them to be easily imported into SQL. The Urban Fire Station Location dataset was collected from the Queensland Government Open Data Source portal, whereas the fire location data was collected from NASA. The implications of these datasets are to provide emergency and convenient information to the digital solution, so it can be displayed visually to the end user. Urban fire station location data has been recorded in a CSV file, recording information regarding fire stations throughout the state. This includes longitude, latitude, station name, address, and locality. This dataset will be utilized in the digital solution to identify fire stations on the live fire map. If the user scrolls in on the map, an icon will appear indicating a fire station. Furthermore, due to the data being in a CSV format, it enables easy modifications. Queensland Fire Tracker will utilize the data with the headings of station, address, long, and lat, as these are relevant towards the user. The headings enable a user to understand the station name as well as its location. The other headings, such as crewing and levy type, are not relevant to the user, as they do not help the user find the fire station location. This dataset is a real-time updating dataset, providing live longitudes and latitudes of fire locations. The data is collected by NASA satellite, MODIS, recording fire data around the world. Data that is recorded is distributed into CSV files for regions around the Earth. The fire data collected for Australia also includes fires that occurred in New Zealand. However, due to the file being in CSV, it can easily be modified to only display Queensland fire data. This dataset will be used in Queensland Fire Tracker to display live fire locations to the user through an icon. Furthermore, if the user clicks on the icon of a certain fire, information regarding the respected fire will be displayed to the user. This information will include date, time, longitude, and latitude of the fire. The data dictionary refers to the database tables that will be present within the digital solution. These tables will utilize the data recordings in the CSV files outlined in the analysis of the datasets. The existing solutions section demonstrates imitations of all the user interfaces that will be present in the final digital solution. The sketches will include annotations detailing both elements and principles of visual communication and usability principles. These are the CART principles demonstrated within the digital solution. And these are the usability principles demonstrated within the digital solution. Feel free to pause the video if you want to read them. Algorithms for the required purposes of Queensland Fire Tracker are represented using pseudocode to show the functionality of the intended design. The pseudocode is displayed in IPO charts: input, process, output. You can pause the video if you want to read each pseudocode algorithm. The evaluation and recommendations section is the evaluation of the criteria and recommendations for future attempts. The evaluation of criteria uses the prescribed criteria, self-determined criteria, and constraints mentioned earlier in section 1.2 to evaluate how successfully the digital solution met each criterion. Once again, you can pause the video if you want to read each criterion, evaluation, and recommendation.